This video is all about how we are going to use fibers and textiles in a forensic investigation. So fibers often fall off and are picked up during normal activities. This is one of the most common cross-transfer of materials. Very small fibers are easily shed from textiles and can become trace evidence. Now I know some of you may be doubting, how possible is it for fibers to actually shed? And I'm hoping you've done laundry at some point in your life, and when you put clothes in the dryer, you've probably noticed that dryer lint. Dryer lint is all of the fibers that have fallen off the clothes while they're drying and been collected in one location, which is why if you have like a hot pink shirt, you may notice that a lot of your dryer lint is hot pink. It is the fibers. So fibers are falling off all the time. In an investigation, collection of fibers within 24 hours is critical. This isn't because fibers go bad or expire, it's because they're so easily lost in the transport of a body or as people move through a crime scene. So we want to collect them quickly to make sure we don't lose them. Fiber evaluation can show such things as the type of fiber, its color, the possibility of violence, location of suspects, and point of origin. Now, in order to make fibers, weaving spun fibers called yarns together produces clothing and many textiles. So it's a big process to go from a fiber all the way up to an article of clothing. Shedding from an article of clothing or textile is the most common form of fiber transfer. We can collect fiber using tape or small vacuums in order to pick up the materials. Natural fibers are only going to require an ordinary microscope to find the characteristic shapes and markings. Infrared spectroscopy can reveal something about the chemical structure of other fibers that may otherwise look very much alike. We will obviously be using just ordinary microscopes in our class, and you're still going to get a good amount of detail. Now, if large quantities of fibers are found, and we will be doing this in class, you can subject that fiber to destructive tests, such as burning them in a flame, and you can kind of see how we might analyze that above, or dissolving them in various liquids. Now, you may wonder why I say we can only do destructive tests if a large quantity is found. Typically speaking, we are not allowed to use up an entire sample when we are doing our investigation, because the defense has the right to their own analysis of the evidence. And if we destroy all of the fibers in a destructive test, the defense can no longer test that evidence, thus making it unable to be used in court. So we can't destroy our entire sample. Crimes can be solved in this way by comparing fibers found on different suspects with those found at crime scenes. So we're going to talk about all the different types of fibers you may come across at a crime scene. First up is natural fibers. Those can include animal fibers, which are made of proteins, wool from sheep, cashmere and mohair from goats, angora from rabbits, and hair from alpacas, llamas, and camels are all commonly used in textiles. And if you want to see something really cute, I really recommend looking up an angora rabbit. So cute, so fluffy. And another animal fiber that you may be thinking about a little less, silk, actually comes from caterpillar cocoons. It does create longer strands, but it's not near as easily shed, which explains why silk is so expensive compared to wool, for example. Another type of natural fiber is plant fibers, and these are made from polymer cellulose. Cellulose is a very common component of plants. Now, plant fibers have become wildly popular, and it's because they can absorb water while being insoluble in water, meaning they don't dissolve in water, which is good. You don't want your shirt dissolving when it rains outside. Are very resistant to damage from harsh chemicals, which means that they hold up well. They can only really be dissolved by strong acids, and most people aren't coming in contact with strong acids. However, they are very common at crime scenes because plant fibers become brittle over time. Now, there are lots of different examples of plant fibers. Those can include cotton, which is what you're probably most familiar with, and this is the seed pods in the plant fiber that is most commonly used in textiles. And I'm sure your history classes have covered why cotton was revolutionary. Coir from coconuts. You're probably most familiar with coir from coconuts, and if you've ever seen those brown Basket liners for flowering plants, those are core, or those brown doormats, also core, coming from the outside of coconuts. Hemp, jute, and flax are from the stems of plants, and these are used in both clothes making as well as rope making frequently. Manila and sisal from leaves deteriorates more quickly. So lots of examples of plant fibers. Now our third classification of natural fibers, and the least common of the three, are mineral fibers. We have fiberglass, which is a fibrous form of glass, hence its name. So fiberglass is actually a mineral fiber. And then probably the most famous mineral fiber, which is asbestos, which is a naturally occurring mineral with a crystalline structure. Now, if you're sitting here thinking, I've heard of asbestos before, Ms. Hinkson, I didn't know it was a fiber. It is a fiber, a mineral fiber to be more specific. Asbestos, when we first discovered it, we decided we were going to use it anything because it's incredibly heat resistant. So we put it in oven mitts, we put it in housing insulation, we put it in firemen's suits. We put it everywhere because of its great properties at maintaining temperature without getting hot or letting the cold in. However, it turns out that if asbestos gets in your lungs, it causes mesothelioma and has made many, many people very sick. And now asbestos is no longer allowed to be used except in some more industrial applications. Now, interestingly, asbestos is only dangerous really when it's disturbed. So there are still houses out there that have asbestos insulation in them, for example. And as long as they aren't messing with the walls of that house, the asbestos insulation is actually fine and pretty safe. But the minute they go all Chip and Joanna Gaines on that house, then they have to remove all of the asbestos, following some very careful procedures in order to prevent anyone from getting sick. Now, our other type of fibers are synthetic fibers, and these are artificially produced fibers. So until the 19th century, we only could use plant and animal fibers to make clothes and textiles. Now, half the products produced today are artificially produced. And almost all the clothes that you get from Amazon or Shein or any of those fast fashion kind of things are almost all synthetic fibers. Now, there are two types of synthetic fibers. We have regenerated fibers, which are derived from cellulose. You'll remember cellulose from our plant fibers, so they're based off of plant fibers, but we've chemically altered them to make them different. Now, the most common type of regenerated fibers is rayon, and it's used because it imitates natural fibers pretty well, but it is stronger. Rayon is most commonly used to imitate silk. If you get something that you think is silk, but it was really cheap, check the tag because it's probably rayon. Another one is Celanese, which is cellulose combined with acetate, and the acetate strengthens it, and we've turned that into carpets. So carpet fiber, once again, is going to look different than clothing fiber for our analysis. Then we have polyamide nylon, which is cellulose combined with 3 acetate units. It's breathable, lightweight, and often used in performance clothing. This is compared to synthetic polymer fibers, our second classification of synthetic fibers, and these are petroleum-based. So the other ones were cellulose-based. These are petroleum-based, which gives them a lot of different characteristics. And these are made by putting petroleum monomers in large vats and joining them together to form polymers and then spinning them into yarn. They have no internal structures and under magnification will be completely regular. Unlike our natural fibers that are going to have a lot of variation because nature, these are going to be very similar to each other. So some examples of synthetic polymer fibers. The most common one, polyester, found in polar freeze, wrinkle resistant, not easily broken down by light or concentrated acid. We used to use polyester just all on its own. However, polyester on its own tends to be fairly stiff and kind of itchy. So we've started mixing it with natural fibers in order to soften it while still keeping that strength. So if you've ever heard of a cotton poly blend, what they're saying is it's cotton mixed with polyester. Then we have nylon. It is easily broken down by light and concentrated acid, but otherwise it is pretty similar to polyester. It's wrinkle resistant, so it is often found in traveling clothes and things that are trying not to wrinkle. We have acrylic, which is inexpensive, but it does tend to ball easily. It is often used as an artificial for wool and fur, so most commonly you see acrylic in sweaters. So if you have a sweater that you've noticed pills really badly, check the tag, it might be acrylic. And last but not least, we have olefins, which is high performance, quick drying, and resistant to wear. So a lot of times you find this in athletic clothing. So to summarize, we have 3 different types of natural fibers and 2 types of synthetic fibers. So as far as yarns, fabrics, and textiles are concerned, fibers can be twisted, which we call spinning or spun for the past tense, into yarn of any length, thick or thin, loose or tight. Depending on what the purpose of that yarn is, we're going to make that choice. This is also the stage where we would blend in different fibers in order to create whatever characteristic we're trying to, such as wrinkle resistance. So this is the stage that we would blend cotton and polyester together, for example. Then fibers can be woven into fabrics or textiles, where the threads are arranged side by side, which we call the warp, and then more threads, the weft, are then woven back and forth crosswise, and this is how we can create our different patterns. Now, obviously, if we find just a small piece of fiber, we're not going to be able to tell about the spin, but sometimes we do find big chunks of fabric, especially if some sort of violence occurred, and this is going to allow us to get a better look at how that fiber was created and might help us get some more unique characteristics. We're going to be having some fun with fiber in class over the next couple days, so come ready for that.